Hello everyone. So I had a request to make a video for determining, sorry about my squeaky chair, but to determine or help in determining asymptotes for rational functions. All right, this was submitted by Devin. Thank you, Devin, for the video request. So the first thing we're gonna do is just kind of start off by, revisiting the definitions because that really is your lifeline, especially when you're on your own trying to work through assignments or study. Definitions are always going to come back to save you every time. So we'll start off with the definitions, then we'll look at some examples, and we'll go from there. All right, so and this video is just for asymptotes. This is not for graphing completely, but if you can get your asymptotes, it does help you to graph. All right, so first things first, we can talk about vertical asymptotes. You can determine vertical asymptotes by setting the denominator equal to 0. All right, so again, if you want to determine your vertical asymptotes, you're going to want to set your denominator equal to 0. All right, so whatever it is, just go ahead and set that equal to 0. And we're just going to go ahead and start with each of these examples by determining their vertical asymptotes. So in this particular example, if we look at the denominator is a second degree equation. All right, so it's quadratic. So it can have up to two zeros or two solutions, right? So we can determine that by taking this and factoring it. Let's see, are there factors of 6 that can subtract or difference to equal 1? And there are. So there's a 1 here, there's a 6 here, and that's going to be 3 and 2. All right, your 3x is going to be negative, your 2x will be positive. So then you have x squared minus 3x plus 2x minus 6. And again, you want to set that equal to 0 to determine these. I'm going to go ahead and group these up. Substitute out or factor out an x from that first term, and then I'm going to factor a 2 out from the second term. I'll put that in parentheses, x minus 3. Now I can factor out my x minus 3, and I'm left with 2 factors. And when I apply the zero factor property, I get both of my vertical asymptotes, right? The locations are going to be at x equals 3 and at x equals negative 2. So if I want to identify what my vertical asymptotes are, they're going to be equations just like this. I'm going to have one equation, x equals negative 2, and then my second equation is going to be x equals 3. So that's how I get my vertical asymptote for that one. For this example, it's a lot easier. It's just a linear sort of equation for the denominator. So I'm able to just set that equal to 0 and solve. And that is the equation of my vertical asymptote for part B. The same applies for part C. Your vertical asymptote is achieved pretty easily here. All right, just set that equal to 0. You're going to have a vertical asymptote at x equals 1. All right, so your vertical asymptote is your first real victory here. You can get the vertical asymptote pretty easily. Again, just setting that denominator equal to 0. Now let's talk about the non-vertical asymptotes. And I call them non-vertical asymptotes specifically, even though, or despite 2 of them being actual horizontal, one of them is oblique. So we can just, or slanted. We can just think about them as non-vertical, and it will cover classifying all of them, right? So as far as the non-vertical asymptotes, we have a couple scenarios that we're going to look for, and they're all predicated on the degree of the relationship between the degrees of the numerator and the denominator. All right, so if the numerator has a lesser degree than the denominator, then the horizontal asymptote is going to be y equals 0 or the x-axis. All right, so let's see if any one of our scenarios has that going on. And indeed, we can see here, I'll call it an NVA or a non-vertical asymptote here, because the numerator is 1 degree or a lesser degree than the denominator. Then this non-vertical asymptote is going to be the equation y equals 0 or the x-axis. All right. Now let's look for any other ones. No, those degrees aren't in that configuration, and those aren't either. So that first definition for the non-vertical only applies to part A. So let's see if there are any others. All right, here we go. If the numerator and denominator have the same degree, then the function's in this form here. So what they mean by the form that they're indicating here for f is that they're in where your terms are in decreasing order according to the degree of the term. So you're going to have the highest degree term first, followed by the second highest, on and so forth until you get to the constant term. Right? So if you have it in that situation, right, you see the leading degrees there and they're the same, right, then that horizontal asymptote is going to have or the non-vertical asymptote, it's going to have this equation y equals the leading coefficient, and I'll highlight that in a different color, the leading coefficient of the numerator over the leading coefficient of the denominator. All right, so we take a look at our cases, see if we have anything that looks like that. All right, part B, it has a situation going on where both of those have the same degree, and the leading coefficient for the numerator is going to be 4. The leading coefficient for the denominator is going to be 1. So the equation for the non-vertical asymptote is going to be y equals 4 over 1, or just y equals 4. All right. Now the last example does not have the numerator and the denominator do not have the same degrees, nor is the numerator of a lesser degree. So we're going to need an additional definition to deal with that one. So let's come over here and take a look at this last part here. So it says if the numerator is of degree exactly 1 more than the denominator. All right. So in order for this to occur, this will be the case. All right. Then there will be an oblique or slanted asymptote. For me, I'm likely to only give you situations where the denominator is a linear factor, just to kind of aid in, dividing those two, and that allows us to use synthetic division. All right. So again, to find it, you would divide the numerator by the denominator and disregard the remainder. And then you set the rest of your quotient equal to y to obtain the equation of the asymptote. All right, so let's look at part C over here, and we can see that the numerator is of 1 degree higher than the denominator. All right, and the denominator is a linear factor, so that's going to aid in us, dividing this, because we can just use synthetic division there. Okay, so let's go ahead and synthetically divide the numerator by the denominator. So that k is going to be a 1, and then we end up with a 1, and a 0 for the equation of that numerator. All right, so now we go ahead and complete synthetic division. That's going to be a 1, this is going to be a 2, that's going to be a 2. And if you remember, the definition said that we disregard the remainder. Okay, so we're going to come back and we're going to disregard that remainder here. And now the non-vertical asymptote is going to be represented by that last line there. So what does that look like? Well, that looks like y equals x plus 2 is the non-vertical asymptote. Okay, so for this question, the non-vertical asymptote or slanted asymptote has the equation y equals x plus 2. All right, so just a very quick recap. We had these 3 problems, the first of which the numerator was lesser was a lesser degree than the denominator. The second, where the numerator and the denominator had the same degree. And then finally, the third, where the numerator was exactly 1 degree higher than the denominator. All right, and based on those, we were able to determine our non-vertical asymptotes, and again, that's based on the degrees. But we can always find our vertical asymptotes by just setting the denominator equal to 0 and solving. So rejoice whenever you have a linear denominator, because finding that non-vertical asymptote, finding the vertical asymptote is going to be extremely simple. I hope this helps, and have a great day. Peace.